What's up, everyone? Welcome back. Patrick here. Moving on to another question where we've got to factor expressions by taking out a greatest common factor. And notice that in these expressions here, we're actually going to be working with fractions, which makes things a little bit more complex. There's a couple of steps that we got to do initially. I'm going to show you how I do this, my personal process. Your teacher, your textbook may show you a different one. I'm going to show you how I do it. I personally like my process because what I do is I initially try to get rid of the fraction. So I take something out initially and then just leave an expression that has no fractions, and then we just work with that expression like we've done with previous ones in the previous videos in this section. It just becomes a regular factoring kind of question. And what you want to do is to take out fractions, you want to make sure that you first have a common denominator between all the fractions. Now in part A and B it's nice because we already have common denominators 3, 3, 5, 5, but notice in part C and D they aren't common denominators yet. So there's going to be a little bit more work in parts C and D, but parts A and B is going to give you a nice sort of preliminary introduction to the process and how it works. I don't want to go straight off the bat into doing too complex of questions. So let's start off with part A. We got 1 over 3. We got x cubed plus 2 over 3 y cubed, like that. And the first thing that I do if I get fractions like this is I convert the fractions so they are common denominators, kind of like you're adding or subtracting fractions. And notice in this case, they already have a common denominator of 3. And so the first thing I do to start this question off is I take out a 1 over that common denominator. In this case, it's 3. So I basically just take out that denominator of 3. And then what are we left with in the brackets? It would just be whatever's up top. So we would have 1x cubed, which is just x cubed, plus 2y cubed, like that. Right? Notice if we take the 1 over 3 and we distribute it back in to the bracket, we would end up with this right there. Okay, so I always take out 1 over the common denominator. And if you do that, what's going to happen is you would end up having an expression that has no fractions, as I mentioned. And that will work for any case you have. As long as you get the common denominator, as long as you convert the fractions to have common denominators, then you take out 1 over that common denominator. Whatever's up top is going to stay as is. And then what I do is I just look at this bracket and just pretend like they're asking me to factor that right there. I forget about the 1 over 3, and then at the end, I bring it back. You got to make sure that you still have that 1 over 3 in your final answer. But as preliminary work, you could then just work with this bracket over here, and you could forget about the fractions and then bring them back at the end. So I feel like that is the best way to do it personally versus trying to work with fractions all at once. Take it out, take out 1 over the common denominator, and then just work with that bracket that you're remaining with. Another thing I want to mention is you're not always, in this case, these are all fractions, but a lot of times you may not even have all of them be fractions. So like let's say we had 5x cubed plus 2 over 3 y cubed, like that. Because we're dealing with a fraction, we want to convert everything to have a common denominator. So notice this 5 over 1, how can we convert it to have a denominator of 3? We would multiply the bottom by 3, multiply the top by 3, so that's 15 over 3. So we would rewrite this as 15 over 3x cubed plus 2 over 3y cubed. And then we take out that 1 over 3 again. Okay, so sometimes you're going to have numbers mixed with fractions. Well, that number is just over 1. Okay, so you still would convert that number to be a fraction like that. And what you would be left with is 15 x cubed plus 2y cubed, like that. After we take out the 1 over 3, 15x cubed plus 2y cubed. You're always going to be left with whatever's at the top because we're taking out the 3, the common 3. That's from the bottom, and then you would just factor that right there. Right, so just wanted to mention that as well. Sometimes there's going to be numbers. In this case, I could have maybe added a question or made one of these a number, I just realized. But just in case you do run into it, same thing. It's just that number. You could think of that number just being over 1. Okay, it's just another fraction. Right, so going back to this question, so we got 1 over 3. And so now we just work with this bracket. I just erased it, so let me bring it back. And we just factor this over here. Now notice in this case, this actually doesn't factor any further because we have an x over here, but no x over here. We have a y over here, no y over here. And then we have a 1 in front and then a 2. There's no factor other than 1 that we could take out. And so we can't factor this any further. So really all we could factor from this is a 1 over 3. That's basically it. So this actually ends up being the final answer for part A. All we could take out is a 1 over 3, which is nice and easy. That's definitely not always going to happen, as you'll see, but wanted to include an example like that to show you it's possible that maybe just 1 over that fraction, 1 over that common denominator is all you're going to take out. Right, let's move on to part B. So we got 3 over 5 x squared y minus 6 over 5 x, like that. First step, convert everything to have a common denominator. It's nice because, again, we have a common denominator already of 5. So first step, take out 1 over that common denominator of 5. That's the first thing I'm going to do. What would I be left with? Well, whatever is up top. So we'd have 3x squared y minus 6x, like that. Right, took out the 1 over 5, and now notice we're left with an expression that has no fractions. And so let's actually work. You know what? Let me give myself some room here. So I'm going to rewrite this. And now what I'm going to do, let me just make sure, yeah. And now what I'm going to do, I'm going to work with just this bracket. So this is going to be like side work. This is the main work here. Here we're going to be doing some side work. So we got 3x squared y minus 6x. And all we do now is we just factor this like expressions we've been doing before. Notice this has no more fractions. So 3 and 6, notice we could take out a 3. We have x and x, take out the lowest exponent, which would be x to the 1, right? And then we have a y here, but no y here, so we can't take out any y. So 3x is the greatest common factor in this expression. So what would we be left with? We would divide this by 3x, the 3's cancel out, x to the 2 over x to the 1 gives us x. We got the y there, minus x's cancel out, 6 divided by 3 gives us 2, like that. Okay, so this expression factors into that. Okay, at this point you should be pretty comfortable going from here to here. We've done a bunch of videos before and factoring those kinds of expressions. So now going back to our main work, basically this bracket over here we converted to these two brackets. So we can rewrite this as 1 over 5 3x xy minus 2, like that. Right, so this bracket factored into these two. We worked with that bracket separately. And so this bracket is equal to this bracket, and then we still got that 1 over 5 in front. And so now what we do to combine these, you can just take this single expression, multiply it by the 1 over 5, so you'd have 3 over 5. 3 times 1 over 5 gives us 3 over 5, and then we have this x over here, xy minus 2, like that. And sometimes this fraction will simplify even further. If this was like 3 over 6, you could simplify it to 1 over 2. In this case, it doesn't simplify. And so that ends up being the final answer. That's it, right? So that's the process. Okay, converting everything to have a common denominator and then taking out 1 over that common denominator to give you an expression that's going to contain no fractions. That's always going to happen. You're going to see with these it's going to happen as well. And then you just work with that expression separately, factor it, and then with this term, with the greatest common factor you took out of that expression in the brackets, you can combine that with the fraction that you took out. Right, and usually you're just going to combine the number here with the fraction. Notice the 3 over 5 we combined. Or if it was just an x here, it'd be like 1x. This would end up being 1 over 5, right? 1 times 1 would give us 1. But in this case, it's 3 times 1, which gives us that 3. And then the x is just remaining by itself. Some solutions you might see like a 3x over 5 like that. Okay, that's another way to show this, but personally, I like to keep the fraction separate and then the x separate like that. Right, so this is another way it could be written, but both of those are the exact same thing. Now moving on to part C, so we got 1 over 12 x to the 4 y to the 2 minus 1 over 4 x to the 3 y plus 1 over 3 x to the 2 y to the 3. So this one's going to be a little bit more complex, a lot more variables, but also if you notice the fractions in this case, they are not in a format where we have a common denominator. Okay, so that's the first thing we want to do. We want to take the 1 over 12, the 1 over 4, let me space these out a bit, and then the 1 over 3, and we want to convert them all to have a common denominator. Now, what's the lowest common denominator between 12, 4, and 3? Notice it's just going to be 12 actually. So this 1 over 4, multiply this by 3, multiply this by 3. This 3 multiplied by 4, got to multiply the top by 4. So we would have 1 over 12. Here we would have 3 over 12. And over here we would have 4 over 12. So what we want to do is we want to rewrite this. We basically want to change the 1 over 4 here to be 3 over 12, the 1 over 3 to be 4 over 12, to have that common denominator. So we would have 1 over 12, x to the 4, y to the 2, minus 3 over 12, x to the 3y, plus 4 over 12, x squared, y to the 3, like that. Right, I think I got everything. Yes, it's all good. Right, so that's the first step. We got to get a common denominator, which we did. And now it becomes exactly like A and B, the same steps. We could take out 1 over that common denominator of 12. And so what that helps us do is get rid of the fractions. We're going to end up with an expression here, as I mentioned before, that's going to have no fractions. We just end up with whatever the top portion is. We just took out this 12 from all of these. So 1x to the 4y to the 2, it's like x to the 4y to the 2, we don't have to write the 1, minus, watch your signs here, the signs stay the same, then we got a 3, x to the 3y plus 4x squared, y to the 3, like that. And again, as I mentioned, we end up with an expression that has no fractions, right? We took out 1 over that common denominator of 12. If we took this 1 over 12, redistributed back in the bracket, we would end up with this expression over here. And then when we simplify those two fractions, we'd end up with this original expression. Okay, but again, we're factoring, so we're not expanding, we're going the other way. Took out the 1 over 12, and now we're good. So now let's just actually work with that bracket. So let's write the bracket. Let's forget about the 1 over 12. And so that's why I like this process so much, because it gets you to a point quickly at the beginning of the whole process where you're not working with fractions anymore. Just convert it, common denominator, take it out, and now you're just working with an expression that you're factoring that has no fractions. So Notice we got a 1, 3, and 4. Can't take anything out for that. We can take out a 1, but that's going to be invisible, quote unquote, in front of the variables. Notice we have an x, an x, and x. So an x is common in all of them. What's the lowest exponent? 4, 3, 2. So we could take out an x to the 2. And then notice y is common in all of them. Y to the 2, y to the 1, y to the 3. We could take out a y to the 1. Right? We could take out a lowest exponent. So what would we be left with in the brackets? So here, let's, there's a lot going on here. So let's just do the side work. Okay, you might be fairly confident with factoring. You may not have to do all of this, but just want to show you all of the work here. So to figure out what we're left with in the bracket after we take out that greatest common factor, we're dividing all of the expressions by that greatest common factor we're taking out. So x to the 4 over x to the 2 would give us x to the 2, subtract the exponents. Y to the 2 over y to the 1 would give us y to the 1, which is just y. Over here, 3 divided by 1 is 3. X to the 3 over x to the 2 is x. The y's cancel out here, so we're just left with a 3x here. 4 divided by 1 is 4. X to the 2 over x to the 1 is x. Oh no, that was y to the 2. No, x to the 2, sorry. Sorry, I didn't notice that. Right? Yes, x to the 2 over x to the 2, that just cancels. Y to the 3 over y to the 1 would give us y to the 2, like that. Yes, it looks all good over here. So those are the terms we'd be left with, and then you just got to watch your signs here. So we'd have x squared y minus this, we're left with this, plus this. When we take out that x squared y, we're left with 4y squared, like that. And if you want to check your work at this point, you can redistribute back in the bracket. Make sure you get this over here. Another way to check is, can you factor anything from here? X, x, but there's no x here. There's a y here. There's a y here. No y here in between 1, 3, and 4. Can't take out any numbers. Okay, so I know there's a lot going on here, but hopefully you're keeping track of what we're doing. We took this bracket, left out the 1 over 12. We took this bracket, just worked with it here, and we factored out this greatest common factor, x squared y. So basically, now we could go back to our main work. This bracket is equal to these two brackets multiplied. So if we write that all out, we'd have the 1 over 12, and then this bracket converts to these two brackets. We'd have x squared y minus 3x plus 4y squared, like that, right? This bracket, all we did was took this bracket, wrote it as those two. And that's pretty much it. For the question, to make it look nicer, what we would do, there's no number in front here, so it's like a 1. 1 times 1 is just 1, so we'd have 1 over 12. We want to get rid of this bracket, make it look a little nicer. We'd have that, x squared y minus 3x plus 4y squared, right? That's how you factor it. We took out the 1 over 12. That's what was common. That was the common factor, and then you had to convert it to a common denominator in order to see that, right? So this ends up being the final answer for part C. And again, personally, I like this kind of format where the fraction and then these variables here, these single variables, they're all separated, but you might see solutions where this part ends up being x squared y over 12, like that, and then you'll have this bracket. Okay, so both of them are the same thing, so don't be alarmed if you see something like this. As long as you're getting these correctly, it's the same thing, right? So that's how you do a more complex problem like that. Now moving on to part D. Same process. This one's going to be a little bit better because what's going to end up happening is in this case we couldn't take out a number, so the numerator was just 1 here, but in this case we're going to be able to take out a numerator. So there's just a little bit more complexity in this one, but this exact same process. We have a couple of more variables to work with. We got 3 variables, but same thing's going to happen. So let's first start off with the fractions. So we got 2 over 3, 16 over 21, 6 over 7. Those are the fractions we're working with. Step 1, convert all of them to have a common denominator. Between 3, 21, and 7, what's the lowest common denominator? It's 21. So multiply this by 7, multiply this by 7, multiply this by 3, multiply this by 3. Here it's already 21, so we'd end up with 14 over 21, 16 over 21, 18 over 21, like that. So let's take this whole thing and rewrite it, but with these fractions to be in that format. So the 2 over 3, that's going to be 14 over 21, x to the 4, y squared, z to the 3, plus 16 over 21, that we're just keeping as is, x to the 3, y, z to the 5, plus 6 over 7, we're converting to 18 over 21. X squared, y to the 3, z squared, like that. Right, did I get all of these? Yes. I like to check my steps every few if I'm working with lots of things like this. So took all of the fractions, converted it to have the same denominator. What's the next step? We take out 1 over that denominator. So in this case, the denominator is 21. Take out 1 over 21. Don't worry about taking out a common thing with the numerators. We'll do that later, just to keep it in steps, not confuse yourself. Always just initially take out 1 over that denominator. What are we left with? All the stuff on the top. So 14x to the 4, y squared, z to the 3, plus 16x to the 3, y, z to the 5, plus 18x squared, y to the 3, z squared, like that. Okay, and now notice, as I mentioned before, as you've seen in previous examples, here you should always be left with an expression that has no fractions. So let's just work with that expression on its own. It's a lot to rewrite, but it's all good. Okay, so how would we factor this expression over here? So between 14, 16, 18, notice we could take out a 2. So we could definitely take out a 2. X, so x to the 4, x to the 3, x to the 2, lowest exponent is x to the 2, right? This one. Y to the 2, y to the 1, y to the 3, lowest exponent is y to the 1. Z to the 3, z to the 5, z to the 2, z to the 2 is the lowest exponent. So that ends up being the greatest common factor that we could take out of that expression. So to see what we're left with, let's do the algebra on the side just to not mess anything up here. I'm doing this on the fly, so I don't want to make a mistake. Right, so we're taking out this greatest common factor. So to see what we're left with from this, take that and divide it by that greatest common factor. Now 14 divided by 2, 7. X to the 4 over x to the 2 is x to the 2. So we're done there. Y to the 2 over y to the 1 is just y to the 1, which is y. We're just subtracting the exponents here. Z to the 3 over z to the 2 is just z, like that. So here we're left with 7 x squared y z plus, right, we have a plus here, watch your signs. Same thing, let's see what we're left with. So we would take that 16x cubed y to the 1, z to the 5, and we're dividing by that greatest common factor we're taking out, z to the 2. 16 divided by 2, 8. X to the 3 over x to the 2 is x. Y over y, those cancel. Then we got z to the 5 over z to the 2. Subtract the exponents, that would give us z to the 3. So over here we'd have plus, this ends up being this, 8x z to the 3, right? After we take out that greatest common factor. And then finally we got plus, what's the last one gonna be? We got 18x squared y to the 3 z to the 2, like that. All right, we've got to figure out what's this divided by that greatest common factor of 2x squared y z to the 2. 18 divided by 2, 9. Cancel. Cancel. Y to the 3 over y to the 1 would give us y to the 2. So over here we'd have plus 9 y to the 2, like that. Okay, so that's what we are. Just a quick check here. Yeah, it seems right. What I'm doing is I'm just re-expanding in my head just to make sure we didn't lose anything. Yes, looks all good. Okay, so that was the work on the side. We basically took this expression, same thing, converted it to those two brackets. So now let's go back to our main work. 1 over 21 2x squared yz squared, and then this over here. Right, so this bracket converts to those two brackets right there. And so from here, we, to make this look nicer, the 2 and the 1 over 21 we combine, so that'd be 2 over 21. And then this doesn't simplify any further. Sometimes this fraction will simplify further. In this case, it doesn't. And then we got the x squared y z squared. And then in brackets, we're left with that same thing. And then notice this bracket, if you want to do a further check, you can't factor 7, 8, 9. Nothing factors from those. We don't have an x here, even though we got it here. We have y's here, but no y here. And then we have just one z over here. So there's nothing we could factor further in that remaining bracket as expected. Right? So this ends up being the final answer. Again, sometimes this, you might see it as 2x squared y z squared all over 21. And then this bracket remains the same. Personally, I like that format right there where the fraction is separated. Right, so that's how you do these kinds of questions. You want to get a common denominator between all the fractions or all the numbers, take out 1 over that common denominator, and then just work with that remaining expression that has no fractions like we've done in previous videos.